Okay, this is a combined science chemistry for TYS for the periodic table chapter. Now this question is from 2002, paper 1, question 10. Now the bar chart shows the period of elements from lithium to neon. Which property of these elements is shown on the chart? Now, so this particular property we're trying to find what is it, and for lithium the value of this property is the lowest. For beryllium is higher a bit. Then after that it would increase for boron. For carbon is the highest. For nitrogen then drops down. For oxygen, fluorine and neon, so it would drops all the way down. So this particular property we do not know what is it we're trying to identify. Now let's look at all these options one by one. The number of electrons used in bonding. Now what is the meaning of this? The number of electrons used in bonding. For lithium is from group 1. Okay, so for group 1 the number of electrons used, so this is lithium, group 1, the number of electrons for all the elements for group 1 that is used for bonding is 1, because for group 1 elements it has 1 valence electron, and in order for bonding to occur this 1 valence electron must be lost. So for lithium the number of electrons used in bonding is 1. For beryllium has 2 valence electron, so this 2 valence electron must be lost for bonding to occur. Okay, then after that if we go across the period, boron group 3, so the number of valence electron is 3, and when a bonding occurs this 3 valence electron must be lost in order for it to be stable. Okay, and then for carbon there will be 4. For nitrogen it has 5 valence electron, so for bonding to occur it must accept 3 electrons to make it 8 valence electron. Okay, so for nitrogen the number of electrons used for bonding will be 3, and then for oxygen 6 valence electron. For bonding to occur it must accept 2 electrons to make it 8 to make it stable, so 2, and then for fluorine is 1, for neon is 0. So if we look across the periodic table, the value for this property would be 1, 2, 3, 4, and then after that 3, 2, 1, 0. So this is very similar to the values shown in this chart. It would go up all the way from lithium, beryllium, boron. Highest is carbon because it has 4 valence electron. Then after that it would drop down. So for this particular question, this chart actually shows the number of electrons used in the bonding, so it's A. Now let's look at other options. The number of orbits holding electrons. Number of orbits, another word for orbits would be electron shells. So the number of electron shells holding electrons. So for lithium, how many electron shells are there holding the electrons? For lithium it is in period 2. Period 1 is hydrogen, period 2 is lithium, so it has 2 electron shells holding the electrons. So all these elements, beryllium, boron as well as carbon, all of them, they are all in period 2. So period 2 means 2 electron shells holding the electrons. Okay, so it cannot be, the answer cannot be this, because otherwise all this bar would be of the same height, because the number of orbits holding electrons, or the number of electrons holding electrons for all these elements is the same, which is 2. How about the proton or atomic number? Proton or atomic number, if you look at it, proton or atomic number, which is the number below. So the number below, as we go across from lithium, beryllium, and then boron, carbon, nitrogen, oxygen, all the numbers, the number of protons actually increases. Okay, so it cannot be this answer as well. How about the relative atomic mass? The last one would be relative atomic mass. So relative atomic mass actually is the top number, the mass number. So as we go across, we have 7, 9, and then 11, 12, 14, 15, 16, 19, 20. So all the way increases. So it cannot be this answer as well. So the answer for this question is confirmed to be A, the number of electrons used in a bonding. Now let's look at the next question. This question is from 2002 November, paper 1, question 11. Now 4 elements in group 7, okay, VII is 7, 5, V is 5, II, so 5, 6, 7. So group 7 of the periodic table are shown. Chlorine, bromine, iodine, astatine. Which combination of properties is most likely for astatine? Now this is clearly stated in the mind map. For astatine, you have to remember the state as well as the color of the vapor. Okay, so it is actually from this part of the mind map. For astatine, as you go down the periodic, as you go down the group, color become more intense. So for astatine would be black, and then also elements change from gas to solid, so astatine would be solid. So for this question, the answer is C. Okay, state at room temperature and pressure is solid, and the color of vapor must be very dark, because as you go down the group, the color become more and more intense or more and more dark. Now let's look at number 3. What is used to decide the order of elements in the periodic table? So the order of elements in the periodic table is determined by the it's determined by the number of protons. Okay, again, this is found in the mind map. Elements in the periodic table are arranged in order of increasing atomic number or the proton number. Actually, you can just confirm it by looking at the periodic table. You can see they are all arranged according to the number below. 1 for hydrogen, and then after that you can go across. The next element would be helium 2. Then after that you have lithium 3, beryllium 4, boron 5, 6, 7, 8, 9, 10. So this number is actually the number of protons or the atomic number. Now this question is from November 2003, paper 1, question 11. Alright, let's look at the next question. Next question is from November 2004, paper 1, question 10. Now, which element in the table is an alkali metal? Now, what is alkali metal? Alkali metal basically is the group 1 elements. Okay, again, this is found in the periodic, in the mind map. Group 1 alkali metals. Why do they call them alkali metals? Because they react with water to form alkali and hydrogen. So group 1 elements. Now group 1 elements, usually react very violently with water, and when they are reacting, you can see them, they are darting around on the surface of the water. They are floating on the surface of the water, and then they dart around. So which means that they are less dense than water. Okay, which means that they are less dense than water. The density of water is 1 gram per dm cube. Less than that, so there will be this number. And then the melting point is not very high but not very low. It's around, this is definitely option C definitely fit into the properties of alkali metal. So the answer is C. It cannot be -7, because most of the alkali metal at room temperature and pressure, they are still in solid form. Okay, if their melting point is -7, they would be liquid at room temperature and pressure. It cannot be this high as well. Usually for ionic compound, the melting point is very high like this. But anyway, this is wrong because the density is so huge, meaning that it will sink under the water. Okay, so alkali metals, they dart around the water. Their density is less than that of the water. Okay. Next question is from November 2005, paper 1, question 10. Now the table shows the results of halogen displacement experiments. Now this is displacement reaction. This is actually from page 2 of the mind map. Displacement reaction is actually from here. So displacement reaction, basically what does it do? A more reactive halogen will displace a less reactive halogen from its halide solution. Now for example, bromine. Now for example, for the halogens group 7, as you go down the group, the reactivity decreases. That means fluorine is more reactive than chlorine, more reactive than bromine, more reactive than iodine, more reactive than acetylene. Acetylene is the least reactive, fluorine is the most reactive. Okay, that is actually that is what is meant by reactivity decreases as you go down the group. Now bromine and iodine. Okay, now for this reaction, the two halogens are bromine and iodine. Now bromine and iodine, which one is more reactive? Then we have to look at this. Bromine is above iodine, so bromine is more reactive than iodine, which means that bromine will displace. Displace means kick out. Okay, bromine will displace iodine from its halide solution. This is actually an ionic solution, Ki. K is potassium. Potassium is a metal, iodine is a non-metal. So it is actually an ionic solution. And this bromine will kick out the iodine. So kick out the iodine, so iodine will be left alone. And then the bromine will combine with the potassium to form potassium bromide. Okay, so this reaction is possible because bromine is more reactive than iodine. Therefore, bromine displaces iodine from the potassium iodide solution. So this is actually the essence about displacement reaction. The more reactive element will displace the less reactive element from its halide solution. Now let's look at this. Okay, halogen added X2 to the halide solution. So this would be an ionic solution. Y2 displaced. So from here we can see that Y2 is displaced. That means Y2 is kick out. Okay, Y2 gonna kick out. Y2 gonna kick out means that X2 is more reactive than Y2. So we can just make a small note here. X2 is more reactive than Y2. And then when X2 is added to this ionic solution, Z2 is kicked out as well, which means that X2 is more reactive than Z2. So X2 is more reactive than Y2. Also, X2 is more reactive than Z2. Okay, now let's look at the second reaction, Y2 and X, no reaction. So this Y2 is not strong enough to kick out the X. Okay, so that means your X, why? Because your X is more reactive than Y. Therefore your Y cannot kick out the X. Likewise for Z, your Y cannot kick out the Z. Now let's look at the last one, Z2 and X, no reaction. How about Z2 and Y minus? Z2 is displaced, which means that Y2 is displaced, which means that Z2 is more reactive than Y2. So Z2 more reactive than Y2 because Y2 gonna kick out by Z2. Okay, so from this conclusion, we can see that the most reactive is actually X, number one. The second most reactive is Z. The third most reactive is Y. Why? Because Y is less reactive than Z. Y is less reactive than X. There are only three of them, so Y is the least reactive. Okay, X is more reactive than Y. X is more reactive than Z. So X is number one. And then for Z, X is more reactive than Z, so Z lose out to X, but then Z beat Y. So number 2, the second most reactive would be Z. So the most reactive is X, second most reactive is Z, third most reactive is Y. So from here we can say that the most reactive, of course, is chlorine. If you look at the position of the halogen, so most reactive is chlorine, followed by Z, right? Followed by Z, right? So your Z is the second most reactive, that will be bromine. And then the least reactive is Y, that will be iodine. So the answer is D. Okay, just now I was comparing it with this. Okay, chlorine most reactive, bromine second, third one is iodine. Alright, let's go to number 6. The next question is from November 2006, paper 1, question 10. Which statement about the elements in group 1 of the periodic table is correct? Group 1, the proton, okay, let's go through these options one by one. The proton number of an element is 1 greater than that of the element above it. So if we look at group 1, the proton number is the number below. So does the proton number, what is the statement again? Proton number of an element is 1 greater than that of the element above it. So that means we compare two, for example, lithium and sodium. Does this number 11 is 1 greater than 3? No. Okay, so it is not the answer. Number 2, they are equally reactive. They are not equally reactive, because as you look at the mind map again, the reactivity of the group 1 elements are not the same. Why? Because as you go down the group, wait a minute, it is not here. Well, I've written down somewhere here. Oh, it's here. See, as you go down the group, reactivity actually increases. Okay, reactivity actually increases as you go down the group, which means that sodium is more reactive than lithium, potassium is more reactive than sodium, rubidium is more reactive than potassium. Okay, so as you go down the group, reactivity actually increases. Why? Because as you go down the group, the valence electron is getting easier and easier to be lost. Okay, because the valence electron will be further and further away from the proton, so the attraction gets weaker and weaker. Okay, that is actually from this part. As size of atom increases, it is easier to lose the valence electron. That's why reactivity increases going down the group. Okay, so they are not equally reactive. They become less metallic as the proton number increases. Less metallic should be more metallic. Okay, they form chlorides of similar formula. Yes, they form chlorides. For example, the first element, lithium, it would form a positive ion, lithium 1+, and then chloride is Cl-. So the chlorides that is formed by lithium, the formula of lithium chloride would be LiCl. How about for the second element, sodium? Sodium is Na, sodium ion Na+, Cl with Cl-, and then the formula of the chloride would be NaCl. Likewise for K+, for the next element, potassium and Cl-, so the chloride would have the formula of KCl. So all these compound actually called chlorides, because all of them have chlorine, and all these chlorides have similar formula, LiCl, NaCl, and KCl, similar formula. So the answer for this would be D. Number 6, the answer is D.